Hi guys! In this video we are going to be talking about writing equations. So in our last note packet we talked about writing expressions, and what we're doing today is very similar. We're actually going to look at these notes quite a bit while we go through this. Okay, writing equations. Let's first define a few things. So an equation, we talked about this a little bit in class. It's a math sentence just like our expressions, but this time it does have an equal sign. So right here for your definition, write math sentence with an equal sign. If you want to draw a little equal sign to remind you, you can do that. Okay, so an expression, remember, is something kind of like this. 6 minus x, x minus 6, those are expressions. When we were writing these, we had a whole bunch of steps that we followed and a whole bunch of words that told us which operation to use. So addition words were things like sum, add, plus, total. Subtraction words, difference, subtract, minus, and so on. In this lesson, we're going to learn one more word that's special. It's the word is, and it means equal. So whenever I say something like 27 is 3 times a number, that means that 27 is equal to 3 times that number. So this is a new word to add to our vocabulary list, is equal. Okay, so if we look at these right here, numeric equations. So remember we have numeric equations and expressions and algebraic ones. Numeric ones just have numbers. So right here, 2 times 3 is 6. See how I said is there? That's how that would read as a sentence. 2 times 3 is 6. 3 minus 1 is 2. 5 plus 2 is equal to 7. 6 divided by 3 is 2. We can see that these are all true statements. These sides are equal. 2 times 3 really is 6. 3 minus 1 is 2, and so on and so forth. If we changed these to become algebraic equations, maybe we didn't know what those numbers were. So right here, I have 2 times some number, represented by A, is 6. 3 minus some number, C, is 2. Y plus 2 is 7. 6 over x is 2. In these, my letters, so right here my A is my variable. We don't know what it is. It's my unknown. C is an unknown. Y is an unknown. X is a variable or an unknown. These are all algebraic equations, and we could solve these. We're not going to do that in this lesson. We'll save that for a later day. But that's kind of what we're working towards. One day we will be able to solve these, and if we didn't know this over here, we could solve this and we could figure out what A would make this true. Okay, so today all we're doing is writing these equations. We're just setting them up. So before we do that, let's review and remember the steps for writing expressions. So if you still have those notes, we can look at those. So steps. Number 1, we circle the numbers or unknown quantities in the problem. So right here we had 6 less than a number. We circled 6 and we circled a number because these were both representing numbers in our problem. Then we underline any operation words. So right here we're underlining less than because that's an operation word. It means to subtract. Then we write the terms and operations below. So we wrote 6, we put a subtract sign, and we put an X. And then we checked for any flip-flop words. Remember these words right here that make you flip the order? Less than, fewer than, more than, added to. All of these mean to switch the order, so that's what we did right here. 6 less than a number X, because X is the bigger one. And then this one was good to go. We're going to follow those same steps pretty much over here, but we've added a couple more. So they're the same as when writing an equation. When writing an equation, the steps are the same as writing an expression, but we're going to treat the equal sign like an operation as well. And whenever we hear the word equal or is, we're going to underline it. So we're treating the equal sign like an operation word by underlining it. We're also going to remember to flip-flop or switch the order when we have words like more than, less than, fewer than, or added to. These are all our flip-flop words, so we've got to look out for those. So we're still following the same things as before. We are just adding a couple more steps because this time we're going to have an equal sign. Okay, let's look at some examples. I know this can be a little bit confusing, but as we practice, it gets a lot easier, okay? So make sure you're following along and ask questions in class if you have them. So this first one, so remember how we can choose what variable we want. On this one, they gave us one to use, so I would like you to use these over here. So the variable, this one says to use an n. So let's look at our phrase and let's circle and underline our numbers and operations. So starting with the numbers, we have an 8 more than a number. We're going to go ahead and circle that. We don't know what that number is. It's unknown, but it's still a number, is 17. Okay, now let's look for our operations. More than. Okay, that's an operation. It means to add. And more than, ding, 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 right there, is a flip-flop word. We've got to look for that. Okay, is, that's an operation word. Now remember, that's our new word. It means equal. So taking this, all we're doing is translating this into an equation. So we're just writing the same thing down, except instead of words, it's going to be in math language over here. 8. More than means to add, and a number is unknown. We use this n, but because this is a flip-flop word, I've got to do it this way, and I should have left a little bit more space. I have to flip these. N is more than 8, so it's going to be, 8 more than a number, so I've got to do n plus 8. Is, put an equal, and a 17. 8 more than a number is 17 is what this says. And remember, because of the commutative property of addition, it doesn't really matter if we do n plus 8 or 8 plus n, but I would like you to practice these flip-flop words. So go ahead and flip it, okay? On this next one, sorry, I'm like losing my voice. We're going to use a variable x. On this one, they say the difference is an operation word. Remember, it's the answer to a subtraction problem. The difference of a number and 4 is 8. So we've circled our numbers. We have our unknown that we said is just a number. And 4 is a number, and 8. Our operation words here are difference and is. I know it says of here. Usually of means to multiply, but in this case, the way that they worded it, the difference of, it's going with this difference right here. It just means to subtract, so don't let that throw you off. Okay, so the difference of a number and 4. So we know that difference means to subtract of a number. That one came first, so it's going to go first, and we're using the x because that's what they gave us right here. And 4 is going to go right there. Is means equal 8. So the difference of a number and 4 is 8. Okay, this last one. 27 is 3 times a number. So 27 is 3, that's another number, times some unknown number. These are my 3 pieces here. 27 is an operation, times, that's an operation, it means to multiply. So if I just write this one out, this one's pretty straightforward. 27 means equal 3 times a number. So I know I'm going to have a number y in here. And remember, when I'm multiplying this number and my variable, this acts as a coefficient. I don't need to write a times symbol in there. I can, but I don't have to. So I can just say 27 equals 3y. 27 is 3 times some number y. If you want to write it as 27 is 3 times a number, maybe I'll do a dot so it doesn't look like an X, 3 times a number, that would also work. But just remember it simplifies and looks like this. Okay. So those ones are pretty straightforward and fairly easy. We've done those before. This next one's going to be a little bit trickier, so make sure you're paying attention to this. Okay, this one we've got to set it up, but they didn't just give us a nice sentence. They said the perimeter of a rectangle is 32 centimeters. Okay, there's no x's or numbers or things like that in here. We've got to figure them out. They did give us a picture though. Remember, perimeter means to add up all the sides. So if I add up all of these sides, it gives me the perimeter. So since this is a rectangle, I know this side over here is going to be equal to an x, and this side over here is going to be equal to a 4. Now I've got all 4 sides, so to find the perimeter, I would add all of these up, and I know that the perimeter, all these pieces added together, is, which means to equal, 32. So if to set this up, I'm going to go 4 plus x plus my other 4 plus my other x is, I write my equal sign, 32. And I'm done. Okay, we looked at something like this yesterday where we were doing, or today in class, depends on when you're watching the video. Okay, we simplified expressions. Yes, we could combine like terms here, and we could simplify this. For this lesson, you don't need to do that, okay? We'll do that a little bit later on. So if you want to leave it just like that, that would be fine. So perimeter, 4 plus x plus 4 plus x, is 32. Okay, this next one is another one that's a little bit tricky. You spend $16, so there's a number, on 3 notebooks and X binders. Easy enough. Notebooks cost $2 each, and binders cost $5 each. Okay, this one has a lot going on, but it's really not too bad. Let's set this up. So you have $16, you go to the store, you're buying 3 notebooks, and you don't know how many binders you can get, but you know that notebooks cost $2 and binders cost $5. Guess what? You don't need to solve this. You don't need to figure it out. All we're doing is setting up the equation that would let us solve it. So binders cost $2, so $2, and I bought notebooks cost $2, and I'm buying 3 of them, so I'm going to do 2 times 3, because for each notebook, I'm spending $2. Okay, then I'm going to spend $5 on each binder that I buy, but I don't know how many I'm buying, so I'm just going to put my X, because that's what they told me right here. Hopefully you're okay with this. $2 for each binder, I'm getting 3, notebooks. $2 for each notebook, it would help if I could say this right, times 3, $5 for each binder, I'm getting X amount. We don't know how many I'm buying. But we do know that I only have $16 to spend. So that is my total, and it's equal to how much I spent. Okay, which is my price per item. Okay. Hopefully these make sense. We can go over these together in class if you have questions. Go ahead and try these. So we give you 3 that are kind of those straightforward sentence ones, and then we give you a couple challenge ones. Try these on your own. I'll check them in class. Bye.